started with what is a radian. Okay, last year you talked about radians and degrees. You all are very comfortable with degrees. Radians, probably still not as comfortable with. By the end of this trig unit that we'll do, you'll be very comfortable with radians because it's what we're going to use more than degrees. Okay, so a radian is a measure of an angle. Okay, and 1 radian means that the radius and arc length are the same. Okay, so if our radius is the same length as this right here, we have 1 radian. That's what that means. That is how a radian is defined. The first thing we're going to work on is converting from radians to degrees, degrees to radians. Okay, this is something that you did last year, so it's going to be a refresher. But I do want to talk about a couple important measurements that we're going to use. Okay, so let's first think about an entire circle. How many degrees are in a circle? 360. Okay. Now, how do we find the circumference of a circle? Remember? Pi times diameter. I'm going to go ahead and write that as 2 pi r, 2 radii, 1 diameter. Okay. So if I have just an entire circle where we are talking about an angle that is all the way around, right? Then our angle is our arc length, well, circumference is arc length, divided by radius. Well, in this case, arc length divided by radius simplifies down to 2 pi. Okay? So, when we have 2 pi radians, that is the same thing as 360 degrees, all right? Or sometimes we like to say that pi radians is the same as 180 degrees. I'm sure that will kind of ring a bell from what you did last year. Okay? So, you guys work on conversions in science, correct? Okay, you worked on conversions back in, I think, even middle school math. All right. Same principle is applied with converting radians to degrees. We're going to use the fact that pi radians is the same as 180 degrees. So, if I have an angle measure of 120 degrees, okay, the degree symbol is telling me that it's degrees. Radians does not have a label. So if you do not put the degree sign, then I assume it's radians. Okay? Just because it has a pi, that doesn't mean it's a radian. It just doesn't have a label. Okay? So if I want to get this to degrees, we need to cancel out the degrees. So where should 180 go? Okay? So we're going to put 180 degrees on the bottom. We know that's the same thing as pi radians, so essentially we're multiplying by 1 since pi and 180 degrees are the same. The degrees then cancel out, and we can reduce this fraction. 120 over 180, ignore the pi for a little bit, reduces down to 12 over 18, which reduces down to, okay, so this is 2 pi over 3 radians. Now we're going to go the other way. Here we have an angle measure of 7 pi over 9 radians. We want it to be in degrees. Since we're changing to degrees, we want 180 in the numerator so we can get that degree symbol over pi. Those are equivalent. So we multiply by essentially 1. Conveniently, the pi's cancel out. And this is something that, we don't have to use our calculator. What's 180 divided by 9? 20 times 7. We have 140 degrees. Okay. I will warn you right now, our test and quiz, this first quiz and for sure our test will be separated into calculator and non-calculator. Okay. However, this is something that I would allow you to use a calculator for. Okay. All right, let's talk about graphing angles. When we graph angles in standard position, that means that their initial side goes here. And then we draw the terminal side wherever we see fit. Okay, so let's remember our quadrants. We have quadrants 1, 2, 3, and 4. That is also how we rotate with our angles. So if we're talking about angles, what angle would we rotate to here? 90. And then if we go all the way to here, we're at 180. Rotate 90 degrees more, we're at 270, and here we would rotate back to 360. Okay. We would also start at 0. Okay, so 0 and 360 are the same measurement. Now let's talk about radians. Okay, we would start at 0 radians. What did we say was the same as 180 degrees? Pi radians. So what would 90 degrees be the same as? Pi over 2. Okay. Now we know all the way around is 2 pi radians. So what would be this 270 degrees? 3 pi over 2. Okay. Those are very important numbers to know. 90 degrees is pi over 2. So each of those go up by pi over 2. Okay. Now we're going to practice graphing these angles. We will start with 120 degrees. Okay. Finn, what quadrant would you say 120 degrees would lie in? 2. Is it closer to 90 or closer to 180? Okay. So here we would put our mark, and we're going to put that little curvy arrow to show that we rotated in that direction. Okay. Now, positive angles rotate counterclockwise, which means if we have a negative angle, which way are we going to rotate? Clockwise, right? We're going to go the other way. So, 750. We're still going to start here. Okay? And we're going to rotate this way, okay? So if we rotate all the way around, here is negative 360, right? If we rotate another 360 degrees, how many is that? What? 720. So then we would just need negative 30 degrees more to get our negative 750 degrees. Okay, so you see that we can see that we rotated twice in the negative direction and then another negative 30 degrees more. Okay. So if your angle is bigger than 360 or negative 360, I should see that you rotated around more than once. I'm pretty confident with degrees that you feel comfortable with them. The radians is maybe where we need a little bit more practice. Okay, so we're going to graph 5 pi over 2. Okay, now remember, 2 pi is once around. Is 5 pi over 2 bigger than 2 pi? It is. Okay, 2 is smaller than 5 halves, so 2 pi is smaller than 5 pi over 2. So we're going to go, I'm going to graph this one in blue here. So I'm going to go ahead and twist all the way around once, and then how much more are we going to need to rotate to get to 5 pi over 2? Just pi over 2 more, right? 5 halves is just 1/2 bigger than 2. So 5 pi over 2 is pi over 2 bigger than 2 pi. Okay. Last but not least, we have 4 pi over 3. Okay. 4 pi over 3. 4/3 is bigger than 1, correct? Yes. So we know that this is going to be bigger than 1 pi. Is 4/3 pi larger than 3/2 pi? It is not. Okay. So 4/3 pi is going to be here in quadrant 3. We say that this is a quadrant 3 angle because its terminal side is in quadrant 3. All right, we need to have a little conversation here. Turn to your neighbor. Come up with a definition for complementary and supplementary angles. Maybe just talk with your pod. We'll do that. Add your pod.
I was thinking it's really funny, like so crazy. I remember little pie circles, you memorize the whole thing.
Okay, pod 3 back there. Complementary, what do you got? What adds up to 90? Okay, 2 angles that add up to 90 radians? Oh, okay. So, Tannen, can you tell me how much would that be in radians? Okay. So 2 angles that add up to 90 degrees or pi over 2. Okay, great. Pod 5. That would be you lovely ladies here. Supplementary.
2 angles that add up to 180 degrees, pi.
Thank you. Okay. Now, I know that you guys can do this with 90 degrees and 180 degrees. So the example that we're going to go through together before I dismiss you for lunch is an example with radians. Okay? We're going to work on 5 pi over 12. We may just do the complement before lunch and the supplement after lunch. Okay? I didn't realize how close we were. Okay? So, if 2 angles add up to pi over 2, then we need to take pi over 2 minus 5 pi over 12. I do not want you to panic because we're working with fractions. You can do fractions, no problem. Okay? Get that idea out of your head. All we need to do is make common denominators. All right? So if we make this a common denominator of 12, we have 6 pi over 12 minus 5 pi over 12. So its complement is pi over 12. It says thank you here. you have this written down, you may go to lunch and we'll pick up where we left off. All right, so we just worked with the complement. So we took pi over 2 minus our angle to find its complement. Were there any questions over that? Okay, so its supplement two angles that are supplementary add up to be pi radians. So we are going to take pi minus our angle. Here again, it would be a good idea to make common denominators. All right, this one's a little easier to do. 12 pi over 12 is the same as 1 pi. So our supplement is 7 pi over 12. So far, have I presented you with any new information? No? So feeling very familiar? Kind of a nice way to start the semester, right? Okay. All right. So, another definition, coterminal angles. I would like you to take a little bit of time and discuss with your pod, maybe you already know it, or what you think coterminal angles would be. Dissect the word if you need to. Okay? Discuss what you think coterminal angles would be.
It's like when you go to the angle, you have the same, but they're just like greater degrees. You do another one and it's like a circle.
What about angles? Okay, well that was a short discussion. Pod Q, do you have anything for us?
We said angles that have the same terminal side.
Angles? That's my angle symbol. Did you guys get that? Looks like an angle. Okay. Angles that share the same terminal side. Is that what you said? Is there an example you can think of for me?
20 degrees, 100, and 380 degrees.
Okay, so 20 degrees and 380 degrees are coterminal because they have the same terminal side. They also have the same initial side. Okay? So what did he do to get from 20 degrees to 380 degrees? He added 360. Okay? What if you went the other way? Okay, we could subtract 360 and say that negative 340 degrees is coterminal. Okay? So our first example is 70 degrees. Okay? 70 degrees lies in which quadrant, Molly? In the first quadrant. It's less than 90 degrees. This is our 70-degree angle. A coterminal angle still begins the same place and ends at the same place. Okay? So Connor, how would we find a coterminal angle?
360.
Okay? And what would that be?
430.
430? With confidence? Okay. Okay. How could we find another coterminal angle?
Add another.
We could add another 360. And that would be?
That's a 90.
That would be 1. Ryan, what else could we do?
Subtract 360.
Okay, we could take 70 and subtract 360, which would be negative what?
2.
Okay. And we could keep going, all right. There are an infinite number of coterminal angles. What the book will probably ask for is like 1 positive and 1 negative, okay? Notice how, Connor suggested we add another 360. If you have a very, very negative angle and you're trying to find a positive coterminal angle, you can add 360 over and over and over and over. Now, when I give you a coterminal problem on a quiz, please do not be obnoxious and give me one that's really, really big, all right? Please be reasonable when you answer these questions. All right, let's do one in radians, 3 pi over 4. Will, which quadrant does 3 pi over 4 lie in? The third. Can you tell me why it's in the third? Tell me why. Okay. That's all you got for me? What is this measurement right here? Okay, in radians, since we're in radians.
Yeah.
1 pi, correct? So 3/4 pi, you're saying is bigger than 1 pi? It is not, right? So where is it? Okay. I would even say that it's between 1/2 pi and 1 pi. Would you agree with that, Will? Okay. So we have 3 pi over 4. Okay. So if we want a coterminal angle, how are we going to find that? In this example, we added 360 degrees. And what are we going to add instead? We're going to add 2 pi. Okay? You can either physically make common denominators or think of 2 pi as 8 pi over 4. So 11 pi over 4 is a coterminal angle. Okay? We could also take 3 pi over 4 and subtract 2 pi. 3 pi over 4 minus 8 pi over 4 would give us negative 5 pi over 4. That would be another coterminal angle. Is this something you discussed last year as well? You all seem to remember it fairly well. When I asked you, when I walked around, you guys, somebody at your table had that answer for you. Next up. Okay? All right, 2 more items of business, and then we will be done. Ready? Okay, arc lengths. This is just the rearrangement of the definition of a radian. Okay? But if we talk about arc length, like this red piece of the circle right here, then our formula is S equals theta R, where S stands for arc length. I don't know why it's S for arc length, but just go with it. Huh? Okay. Here's the deal. Since the definition of a radian is that theta equals arc length over radius, theta always has to be in radians. For this formula to work, theta has to be in radians. That means if I give you an angle in degrees, what are you going to have to do with it? We're going to have to convert it. Okay? So please keep that in mind. I would write this down with a big star by it so that you remember that that needs to be in radians when you use it. All right, while we're waiting for people to finish writing that down, get out your calculators. You will need them for this next example. Remember how I mentioned that some parts will be with a calculator, some parts will be without. These next two examples would be with a calculator. Okay. Co-terminal and supplementary complementary, that would probably be without a calculator. So you're going to have to do those fractions without. Okay. All right. So I want to know the length of the arc. Okay. Arc length, length of the arc, means the same thing. Cut off by a central angle of 30 degrees in a circle with a diameter of 3.6. Okay. So first of all, I see find the length of the arc. I'm going to write down this formula, and we're looking for S, the arc length. Now, they do not give us very nice information. First of all, the angle is in degrees. That's not what we want. Second of all, they give us the diameter. So they give us everything we need, but we have to do some work before we can actually plug in those values. So if theta is 30 degrees, okay, what do we multiply by to convert that?
Pi over 1.
Okay, good. Pi over 180 degrees, so the degrees cancel. The fraction of 30 over 180 reduces down to 1/6. So we have pi over 6. Some of you may even remember that those two are equal from last year. I don't know how much memorizing you guys had to do. How much memorizing did you do? That's what I thought. Okay. Okay. Then, if our diameter is 3.6, what does that mean about our radius? 1.8. Okay. So our arc length is pi over 6 times 1.8. What does that give us? .942. Okay, let's talk about labeling here. Radians doesn't have a label, and we multiplied by inches, so arc length is just in inches. It's a piece of the circumference. Okay, so it's a one-dimensional measurement. In your book, you may have problems where it gives you theta and r. You may have problems where it gives you the arc length in r or the arc length in theta. Okay, they'll kind of do some different things with that. Okay. Last but not least, let's go ahead and make this a two-dimensional problem. Okay, so first we talked about the length of an arc. Does anybody know what this is called right here if I color it in? A sector. Yes. Okay. The area of a sector is 1/2 theta r squared. Where once again, theta is measured in radians. It gives you the area of just that piece of pizza. Yes.
I think that a great class on TV would have brought us all pizza and we each had to calculate
Yeah.
the area.
The area of your piece of pizza.
Whole pizza.
What did you say?
I'll take a whole pizza.
You'll take a whole pizza and calculate that area. Who has the best pizza? How did you?
Mom.
Papa's John's got some dinner.
Mama's is
Mom and
Mama's is. Casey's breakfast pizza is hard.
Marco's pizza.
Martha's pizza is surprising.
Underrated.
Yes. Okay. So, last example. I am telling you that the sector formed by an angle of 15 degrees has an area of pi over 3 square centimeters. Find the radius. Okay, so the pieces of information we need to know. Central angle of 15 degrees. Area of pi over 3 square centimeters. What is R? Okay, so first problem, our first issue is that our angle is not in radians. So Zach, what do we multiply by to get it into radians?
1/2.
What do we multiply 15 degrees by to get it from degrees to radians?
Multiply by pi.
Pi is a part of it, but we can't just multiply by pi, we have to multiply by 1. So what's the same as pi? But degrees. How many degrees is the same as pi radians? Put it up.
Oh, 180.
So if we multiply by pi over 180, we're not changing the value because it's like 1. Okay, the degrees cancel. And 15 over 180 reduces down to what? 112? So we have pi over 12. Okay. Now it gives us information about the area. So area is 1/2 pi r squared. That's the formula we just wrote down, correct? Okay. Our area is pi over 3. Nope, that's not the formula at all. 1/2 theta r squared. So that's not right. So we have 1/2 times pi over 12 r squared. So now it's a matter of solving for r. So we have pi over 3 equals pi over 24 times r squared. We want to divide this pi over 24 over. Do you agree? Well, if we have a fraction, dividing is the same as multiplying by the reciprocal. So r squared really equals 8. Now, when we square root both sides, technically we're supposed to say plus or minus, but can we have a negative radius? We cannot have a negative radius. So our radius is 2 square root of 2. Since our area was in square centimeters, then our radius is going to be in centimeters. All right. A lot of today's lesson feels very random, okay? There's a lot of random pieces of information that you know, and it's going to build our foundation for moving forward, okay? So, look at your gold sheet. You should have something that kind of looks like this, except I have highlighted which ones I really need you to do and which ones I think you should do. Okay. Remember the bolded underlined ones are required. The rest I still think that you should do. As a reminder, I